Dr. Madhu Thangavelu conducts the Graduate Space Exploration Architectures Concept Synthesis Studio, which is really hard to say in one breath, at the Department of Astronautical Engineering within the Verturby School of Engineering at the University of Southern California. Very, very long title there. He also teaches the Extreme Environment Habitation Design Seminar at the School of Architecture, where he is a Graduate Thesis Advisor. Professor Thangvelu's educational background is in architecture, a master's in building science, USC and engineering, a bachelor's at Calcutta, India. He is a co-author of the book, The Moon, Resources, Future Development and Colonization. And the second Springer edition was published in 2007. He's also the invited author of a chapter, Living on the Moon. And he's received a couple awards. He was on the USC team that won the coveted NASA Nayak Phase 1 and 2 for developing robotic building technologies on the moon. He is a faculty at International Space University, and I love that school. So thank you very much, sir. Really glad to have you here. Please take it away.
Okay, let me get on here. I want to make sure I have my slide. Thank you all for your patience. It's beautiful to see Ben's presentation followed by Grant, and I'm happy to be watching this, Michael. I mean, so many new ideas, and it's all about, this whole endeavor is about keeping the human creativity and the imaginative faculty going for all of us. And, that is the class that I teach at USC. Some people call it blasphemy, but the idea is to engage people in creative ways. So I have a foot in the School of Architecture and in the School of Engineering. And that is really the reason for this class. As you know, USC has a very interesting astronautical engineering program. It's not a aerospace engineering program, very different. And our famous alumnus is Neil Armstrong. He was at school while he was assigned to the Apollo mission. And our class is nested within this program. Okay. So it's a 3-unit class. We meet once a week. And all I ask is give me something creative. It doesn't have to be correct. It doesn't have to be real, but it has to be imaginative. And we are academia. So we say things that are independent of the industry or the agency. And I asked them, hey, listen, give me a squiggle. A squiggle is better than a lot of plots and charts. We'll figure out the engineering later. So every class starts with this, and in the last few years, we've been talking about Artemis and Gateway. And I keep impressing on them, if you don't do things fast, you will just stay and keep what we call, the standing army problem, and also Parkinson's law comes to mind. That you give people money, they'll find ways to spend it. The main idea here in this presentation is to get you all to go to our website, take a look at the things we've been doing since about the year that Grant's company started, 1992-93. And that is our book. And 2 editions are done. The 3rd edition of the works, and I'm losing my hair. And Buzz Aldrin wrote the foreword. And he is a regular visitor, sometimes incognito, because he charges a huge honorarium. He comes into class and does some wonderful things. You can go check out the videos in the class about the class. I think all of you may have talked about Gateway and the NASA narrative, which talks about how we are going to do. It's very logical It's very easy to understand, but we have a problem. It is very, very complex. It involves a lot of systems, not only from our agencies, but from all over the world. And to give you a rough idea, they have an idea called the near rectilinear halo orbit. It was necessitated by the systems involved, the international partners involved, and just the orbital dynamics is so very constraining that even though this problem was solved 250 years ago, we don't think at USC this is probably the right way to go about like doing gateway. As you know, Earth is here, we got the moon here, L1, L2 on the other side. And so you can fly something here, and over a period of time, the moon, the earth, and the sun will slowly move you from an ecliptic orbit to a near polar orbit, and that's the plan. It's propagated by people here, including Kathleen Howell, and it's something to think about. Now, in our studio, we've been looking at orbits for some years. In fact, these are the few that I picked up that hopefully you'll go to our website, take a look. In 2015, a student came up and said, we can do what we call a super-synchronous Earth orbit that starts over here, goes around here, comes close to L1, and goes back in. And his idea was to use it for lunar tours. The paper got a lot of hits, and you can Google it too. I think it's all over the place. So it's a 7-day orbit. Good idea for a tourist. In the 2016 project, again, if you go into our slides, you'll see, they talked about having L1 as a place to propose a gateway that would really be studying deep space radiation on animals, because there are some ethical considerations about putting people in these places during a solar storm. 2017, Kathleen Howell from Purdue publishes the NRHO along with her team. And Diane Davis, who is at JSC now, is also responsible for many of the charts dealing with NRHO. Centipad is something that came about talking about landing pads. Everybody talked about dust and debris. There's a solution there. In 2018, we talked about using the low Earth orbit as the building and servicing platform for anything beyond there going towards the moon. 2018 had two or three other interesting papers, including one called the Artemis station at L1. And we also discussed what good things we could do using the NRHO, which obviously is servicing the South Polar region. In 2019, a paper came out called Maxim, in which we said, we have to think about what we have done in the past and maybe use that as a stepping stone to inform the world where we've been and what we can do together as a free world with free world values. In 2020, we just had it last year, this particular orbit came back to haunt us. And the student said we could do a 14-day supersynchronous orbit that crosses the moon. And that could also serve as a potential profile for gateway, and had a lot of interesting things going with it. Now, we all agreed that the lunar South Pole is a terrible place for a crew landing, particularly the first Artemis 3 crew landing. There are many things in the many blasphemous stuff in our report on that. So NASA's evolutionary plan is was set in the last administration very clearly, Moon to Mars. But still, all of the elements are not clear how we are going to do this. And some of the performance metrics are interesting. Of course, the schedule takes forever. Again, remember Parkinson's law. And budget is always too difficult. And throw the monkey wrench into the system, the vice president during the last administration said we wanted to accelerate this. It's the right thing to do because you can spend a lot of money without doing anything. So narrative, the way you tell a story, is perhaps more important than how we go about it. Because once you tell a story very clearly and carefully, it's part of the policy. Once you say that, you can do things because the large workforce you employ gets a very good idea of the narrative. Public engagement is very important. And we must dare mighty things. I think you all saw that parachute and how we got the code out of that parachute. I think that that phrase is attributed to Teddy Roosevelt. So the NASA narrative problems are a focus is missing, global appeal is waning. There are two projects now. Gateway came first, but Artemis was pushed in to go earlier. So they're wrangling these two. And it is compounded by things like the Artemis Accords, certain laws that were passed earlier on. And it is seen in the international scene as provocative and sometimes unilateral. All you do is look up Russian news and you'll hear some of this. Can we rework the narrative? I think it's very difficult. So in the 2019 team project, we looked at what we call the Artemis Maximum Project. And the idea was who is going to fly the first two people and where are they going to land? The last section it dealt with what we call the Hermes mission. Hermes, as you know, is the stepbrother of Artemis. What do? You fly Earth to station, from station to Mare Tranquillitatis, visit the pit, the pit that Grant showed, do some wonderful science there, and head on to the Apollo 11 landing site to survey and to preserve the site. On orbit, the crew will continue a telerobotic mission to the Apollo 17 site. And over time, we want to establish a lunar tourism trek that would take you from the Apollo 11 site all the way to Apollo 17 site. Talk about narrative, pretty clear. So where would it all begin? We can use the existing stable of rockets now internationally to get a lot of things happening in low Earth orbit. Low Earth orbit is where the action is. I know all of you know this because we are pumping a lot of satellites into orbit, but that is where we can really do some good things. Station is involved. A station may not be the best trajectory and the best inclination to get to the moon, but we can do this. And of course, Axiom and others are planning other stations, so this is a possibility. From Earth orbit, we can fly after docking with fuel in orbit. We can fly off and do magical things around and on the moon. What would a traverse look like? You'd get down zero on day one or day zero. You'd start at Mars pit. You'd spend some time there. I think this a little bit, it needs to be clarified again. It needs to be cleaned out. And then you drive down 450 kilometers on a beautiful pressurized rover to the Apollo 11 site, where we'll do some more things and then fly back. And those purple lines, can you see them? That is the ground track of the command module. so that they can continue to monitor this mission as well as do the telerobotic side of it, going towards the Apollo 17 site. So that's what we could do. And guess what? We go to the Apollo 11 site, visit it, and preserve. You'll hear more from Michelle about this. Preserve the boot prints, which I'm quite confident they're not the way they look like when it was impressed on the lunar surface. So that was about, and the idea was to let the Apollo people know that that we honor them and we cherish the historical, the heritage that they put to us 50 some years ago. So then this last year, we did the Twins project. And it talked about the various things that are in operation with CLIPS and these terrible landers that are being proposed, of which there should be no doubt. This is the clear winner, because just from the cost point of view. But then you're asking, why are we doing this when 50 some years ago, we produced one of the finest landers the world had ever seen? And we used it, reused it, and saved our crew with it. Why are we redoing and reinventing the wheel? So we got all these problems, and they have to really hash it out and clean it out in the coming months and perhaps 1 or 2 years. So I think I mentioned this to you. We think we can do this very simply along the ecliptic, go to the moon, do all the wonderful things we want to do. And one idea was we will publish a paper soon on this, that the idea of a super-synchronous orbit with something very special, with solar sails to do attitude control. And what you would do, as you see, here's the moon, here's Earth, and we would push it around here. That is the simpler super-synchronous orbit. But in our case, we would just go around like so, come around this way. And a lot of papers exist in this area. We've studied it in the Mobius, and for the Archer mission, we think this is the way to go about it. And it has some very interesting features, including what do you do during a solar storm as Gateway and Artemis are ramping up at the same time, our sun is. The sunspot cycle 25 is starting to emerge. And if you are even in the amateur astronomy community, you'll start to see a lot of images of sunspots coming up. And so we're going to have a very active period pretty soon. So we think public involvement is important. If you have beautiful structures out there, people should see it. If you have solar sails on Gateway, you'll see it orbiting the moon. And one more thing. How much time we got, Michael?
Just a few minutes.
Okay.
I know you started a little bit late, so I was going to give you a little bit, but only about 5.
One more thing about Artemis Accords and how we can sweeten the deal. I think we should have an idea to continually put into use laser communications. And we can do this. It's already being proposed. It's been already done, but now we've gotten better at it between the moon and the Earth. And we think we can, let me see here. We can transmit a lot of data very securely for the different participants. And we already know this capability, and these things are not very expensive, which means we can tie it into the Earth's existing optical terrestrial network. and offer this as people who join the Artemis program to enhance their terrestrial global networks. So this idea was proposed in the class, and we call it SEON. So, and I think NASA has plans for an extensive communication network, and this could really be a glue, a binding technology for bringing people on board Artemis. And of course, every meeting you'll hear this term, sustainability. The lesson for the agency is to do what they're doing now in a much bigger way. Be not just a partner, but be a customer, a real customer. Right now, anybody who talks about space commerce, they're not saying real commerce. They're just being vendors of some sort or the other. So sustainability means real profit motive and to run and sustain your business. And it really means you have revenue and you deduct the cost and you have profit. I think you know this mission that's coming that Elon Musk wants to do. It is going to change everything that we know about. And let me just finish with this. I think this was done at 4 a.m. Policy matters. All of us in the technology arena used to say, "Oh, damn, the policy guys getting in the way." No, policy is cooked from experts who know technology, and the underlying policy philosophy for the United States of America is to promote free world values. Cislunar space is a policy arena. It is not a technology or a science arena. And this you must drill into us, all of us, that the moon is very close to Earth, and this domain, whoever dominates it, will be the next power to reckon with. I think we know this. We can, I think, separate Gateway and Artemis in some way. I'm thinking the Gateway could be a very international endeavor, and Artemis could be more of an American endeavor. And Artemis 3, instead of the pole, should really go visit and survey and preserve the Apollo site while doing some wonderful science, because Providence has put a nice lava tube we call the Tranquillitatis pit right in the middle between Apollo 11 and Apollo 17 descent stages. We can promote global cooperation with, like I said, the sweetener say that, hey, we can enhance your terrestrial global network using optical technologies we use for space, use it for that as well as for regular commerce. Now, space companies are changing everything we know about space technologies. All of us, including yours truly, have depended on NASA and continue to depend on NASA to do our work. But that will no longer be. So, profit motive is important to make real sustainability work, and space tourism is on the horizon. Please go to this site. Take a look at this. We've been doing this since 1992, I think, 93, but these are the only ones I've lined up. Take a look at them, and you'll find all the terms that NASA uses, all the topics have been covered, and you have some references, but it's in blue because I'm not ready to share them with you. With that, I'm done, Michael.
Thank you, sir. We do have to move on pretty quickly,
Okay.
but post the
I will send you.
Post the image, 2 images back, 2 slides back that that library of content, because that's real. I really want people to go look at that.
Yes, that is the main plan behind this talk.
Yeah.
Michael, thank you so much.
No. Like show it for a little bit longer, because we have a lot more people on the internet watching than we have in this call. So I want to give people a chance to kind of see that.
This one, right?
Yeah, correct.
Okay, great. You can do the QR code on it and quickly go to the site. And
Sure.
I usually monitor that site on a weekly basis to see who's hitting it. 2 months ago, China came in.
Okay. Sure.
A few years ago, Russia has been watching.
Yep.
And for all you know, you got Kazakhstan in there. It's very interesting to see how it works.
It's a heck of a resource. It's a heck of a resource.
Thank you.
All right.